Hello, we are the Republic Mountain Lake Senior Design Team in the Electrical Engineering Department. Our sponsor is Republic Mountain Lake LLC, and our faculty advisor is Professor John Lukowski. So in Republic, Michigan, Republic Mountain Lake LLC has an old, abandoned, open-pit mine that they wish to redevelop into a renewable energy site. So the alternative energy enterprise has been tasked with developing generation for the site, and then this Republic Mountain Lake Senior Design Team is to develop a plan for a substation to reliably and safely connect this generation to the power grid. So here's a little overview of the site. So as you can see, there is red, which is the existing 138 kV power infrastructure. And then there is the lighter blue, which is the Alternative Energy Enterprise's proposed locations for a solar field as well as pumped hydro. And then the dark blue is plans where we would put in a new substation as well as a new transmission line to connect to the power grid. So how exactly does our project fit into the power grid? In a typical system, you have generation, which is shown in the bottom left, which connects to transmission, which then connects to distribution, which will then connect to the customers. So our project fits in the generation side, where we step up the voltage from the generators, which will be solar and pumped hydro, and possibly wind in our assumptions, and step it up to a higher voltage for more efficient transmission. So our project is assuming that there are around 185,000 solar panels, which are rated at 400 watts each. This produces an array size of around 74 megawatts, and we are scaling this up to be around 100 MVA substation capacity to account for any other generation on site as well as future expansion. Here's a one line of our design. At the top, you have the 138 kV transmission line coming into a 100 MVA transformer, which steps the voltage down to 34.5 kV. From there, it splits into two zones, one on the left, which is for solar, and one on the right for pumped hydro, wind, and a local power feed. Breaking it down a little bit more, this is an overview of our protection. So on the top, there's a line protection, which is in zone 4, which protects the transmission line leaving the substation. In the middle is a transformer protection, which protects the transformer from any possible faults or short circuits. And then on the bottom left and the bottom right, we have two bus differential zones of protection. These zones help protect the buses from any faults which could arise from objects falling on the buswork or animals that infiltrate the substation. From that one line, we then developed the physical layout. So on the top right, you can see the pink, which is a 138 kV transmission line coming into the substation. It goes through a breaker, into a transformer, which steps down the voltage to 34.5, which is outlined in green. Then from there, you can see on the middle left, we have the first zone of protection, which then has the solar and the capacitor banks. And on the bottom is where we have the pumped hydro, wind, and local power feed. In conclusion, this design can accommodate up to 5 distribution lines supplying or receiving power. We designed the project to be 100 MVA so that we can account for any future solar, wind, or pumped hydro. And this project can be modified and scaled down as needed, as there are still some items that need to be addressed as far as which generation and how big they will be on the site. Prior to another team continuing on this project, we believe there's some additional information that will be required. The first is specifics on the generation that will be developed at the site, such as the size, type, and specific data sheets. Next is the location at the site which are available for a substation and which locations are off limits. And finally, a timeline for development. We would like to extend a special thanks to first our sponsor, Roger and Wes from Republic Mountain Lake, our advisor, Professor Lukowski, the Alternative Energy Enterprise and Noah Balliet, Casey Strom and Mark Kohler, who are industry professionals who volunteered their time and experience to help our project, as well as Len Switzer from the MTU Enterprise Program, and the ECE Senior Design faculty, Dr. Pinar and Professor Hassel. And here are our video and team credits. Thank you for watching.